Hello, how you doing? It's MrDoTheMath here. And today we are going to talk about complex numbers, right? All right, so complex numbers are basically this. We're dealing with imaginary numbers, and it's going to be different. And so please ask questions, right? So here we go. If you have the square root of any number r, if r is a positive number, the square root of a negative r, right? This basically means that it's going to be the square root of -1 times the square root of r. The square root of a -1 is I, and r is just stay inside. And so the answer is I times the square root of r, right? I means imaginary, right? So this is the math, this is the idea of everything today, right? So to undo this, if I square this, I would end up with -r, right? This is 1 and this is the 2 part, right? So if I use the example that they have here where it says -3, right? You see the square root of -3? You'll have the square root of -1 times the square root of 3, right? The square root of -1 is I, and the square root of 3 is 3, because 3 is not like factorial, okay? So now when you undo it, when you square this, you end up with I squared and the square root of 3 squared, right? The square root of 3 squared, when you square the square root of 3, you get 3, and I squared stays. The I squared is equal to -1, right? So you end up with -3, right? So basically, the rule is I squared equals -1, okay?
What is it?
So I squared is -1, it's in the top corner. I squared equals -1, and the square root of -1 is I. This is essentially like the main rule so far, right? I'm gonna go somewhere with this, okay? Now, let's practice taking the square root of negative numbers, right? The square root of -25 is the same as the square root of -1 times the square root of 25. Our rule is the square root of -1 equals what? I. And 25 is a perfect square, so you can break this down to be what? 5. So then your answer would be 5i. Okay? Number 2 is the square root of -72, right? It's the same as the square root of -1 times the square root of 72. Square root of the square root of -1 is I. And 72 can be broken down. It's not a perfect square, so we're going to break it down, right? So that's going to be, if we look at it, think about your perfect square. What's the biggest perfect square that can go into 72?
9.
9? You can go higher.
12.
12? You can go a little higher. 12 is not a perfect square. 16? You can go higher than that. Let's do it. Let's go. Let's break it down. 2 divided by 72 is what? 36. 36, is that a perfect square?
Yeah.
Yeah, that's 6 and 6, right? So we can pull that 6 out, right? So you have 6 root 2, right? And you bring that I down. So it'd be 6i times the square root of 2. Okay? So essentially what you have is 6 times I times the square root of 2. Okay? That's that's the simplification of this imaginary number. Okay? Now we've looked at a perfect square, a negative perfect square. We've looked at a negative number that has to be factorized, right? We made our factor tree. Now we're going to look at a situation where we have a negative number on the outside, -5, times the square root of a negative number. All right? When it comes to square roots, we're done with this -5. It just comes down, right? So basically we're dealing with this -5 times the square root of -1 times the square root of 9, right? So again, you can't do anything with this -5 yet. So it'll just be -5. The square root of -1 is what? I. And the square root of 9 is?
3.
3. So now we have -5 times I times 3. What can be multiplied? The 3 and the 5. So you end up with negative 15i. Okay? So that's that. Now we're going to look at complex sets. We're going to look at sets of complex numbers. Sets of complex numbers. All right? That's essentially a plus bi. Right? A plus bi. Right? And so complex numbers have the form a plus bi. Right? And so subsets is this. If b is 0, so if b equals 0, then a plus 0i equals a. Right? So it's basically being 0 times this I is 0. It cancels out. Okay? In the case that a and b are numbers, right? Not 0, then you're left with just a plus bi, which basically means that a and bi are not like terms. So if a was a number, like say if a was 6 and b was negative 2i, to simplify this, it would just be 6 plus 2i. You can't do anything with it, right? And then the final part, pure, if a equals 0, right? And you have this a, you'll have a plus bi, and a is 0, it'll be 0 plus bi, then the answer is just bi. Okay? There's nothing there. Okay? So what I'm saying is, right now you treat I as if you would a variable and not an actual number. Because again, it's imaginary. Right? So let's look at this example here where they say 3x minus 2i equals 12 plus yi. Right? This section right here is going to make more sense down here. Okay? So now, what you want to do is identify what's the real numbers. Which situation is real here? Which pairs of situations are real? What's imaginary? Who has I?
Negative 2.
Negative 2 and y. So these are imaginary. And these are real. So in this situation, they said find the values of x and y. So solve for x and y. Because you have a real pair and imaginary pair, you can break those up to two situations. So you can break that up to be 3x equals 12, and you'll have negative 2i equals yi. Okay? Then from here, you just do the math, right? How would we solve for x? You'll divide by 3. So x equals 4. Now here, how do you solve for y?
Divide by I.
Divide by who? I. Yeah. Divide both sides by I. Right? When you simplify that, these i's will become 1, or cancel, and you end up with negative 2 equals y. So y equals negative 2, and x equals 4. Okay? So here what we did was we put reals together and we put imaginaries together. Okay? Now let's do some math. Some math with these imaginaries. So you got 2 minus I minus 6 minus 8i. Okay? First thing you want to do is distribute this negative sign through. Right? So we'll have 2 minus I minus 6 plus 8i. Then from here, we combine like terms. What's your like terms here? 2 and negative 6. And negative I and 8i. So 2 minus 6 is negative 4. Negative I plus 8i gives you 7i. And this is your solution. Imaginary numbers always come last. Right? So you got your variable terms first, your whole numbers second, and then your imaginaries last. Let's look look at this example, number 6. 2i minus 4 minus 3i plus 8. Again, distribute this negative sign through, so you're going to get 2i minus 4 plus 3i plus 8. Then combine your like terms. So you got your negative 4 plus 8, and you got your 2i plus 3i. Negative 4 plus 8, 4, 2i plus 3i, 5i. Right? Cool. Now, let's go to this last part, and then I will leave you be. All right, so we'll come over here. Remember I said I squared equals negative 1. Okay? When you have a situation like these where you're double distributing, 3 minus 7i times 2 plus 5i, again, you treat these like variables mathematically, and then we'll apply this rule at the end. So double distribute. First times first, that's going to be 3 times 2, which is 6. Outer times outer, 3 times 5, 15i. Inner times inner, negative 7i times 2, negative 14i. And then your last terms are negative 7i times 5i, which is going to give you your 35i to the second power. Okay? And then we simplify. Right, so it'll be 6 plus I, 1i, positive, it's negative, different signs subtract. And then this negative 35, I squared is basically negative 35 times I squared, which is negative 1. Does everybody see that? Give me a head nod. That I squared equals negative 1. So then we simplify. So it'll be 6 plus I plus 35, because negative 35 times negative 1 is positive 35. Combine your like terms, what you get?
41 plus I.
41 plus I. And that is your solution. Okay? So we combine our like terms. Alright? We got some time. Let's solve. Let's do this solving example. Or do you want to do the other one like this right fast?
I don't know.
Y'all good with
Yeah.
it?
I think so.
You think so? Alright.
Yeah.
Let's do number 10 then. Number 10 says 2x squared minus 11 equals negative 47. We're going to solve this. Right? We're solving. So the first thing you want to do is you want to isolate this variable. So we're going to add 11 to both sides. Plus 11 plus 11. So you get 2x squared equals negative 36. Right? Then we divide to isolate. Divide by 2. X squared is going to equal negative 18. Okay? Then we're going to go all the way back to yesterday, right? X squared. We're going to square root it to get rid of this square. So you get x squared. It's x equals, right? This is the square root of negative 1 times the square root of 18, right? So we'll have plus or minus I for this negative 1. And then we simplify this 18, which is 2 times 9. We pull this 9 out. So you'll have plus or minus I times 3 times the square root of 2. Right? So your answer is plus or minus 3I root 2. Yeah? You good?
Yeah.
So the main thing is the square root of a negative number is I times the root, right?
Right.
And I squared equals negative 1. Okay? If you have any more questions, don't forget to comment below. Don't forget to like and subscribe. MrDoTheMath out.